Welcome back, guys, to the next video of IPv4 addresses. In this video, we are going to look and go into the concepts of classless addressing and why do we require classless addressing. So let us just begin. Okay, before I talk to you about what is the concept of classless addressing, I would like to give you a brief overview, like why do we require classless addressing. So like in the case of classful addressing, there are certain classes that there are certain IP addresses which we declare into, which we divide among different classes like class A, B, C, and D and E. But what will happen, let's suppose if I want some sort of customized number of hosts in my specific network. So let's suppose in class A, it only says that you will be getting 128 networks, and for each network you will get approximately 16 million. I guess there were 16 million hosts that will be available. But what if you require certain number of customized hosts that you require? Let's say you just require 1,000 hosts, but if you require just 1,000 hosts, then you will have to go and look for some other classes. What I'm trying to say over here is that let's suppose there is class A and there is class B. In class A, it says that it will provide you 16 million hosts. In class B, it says that it will provide you some 1 million or 2 million hosts. But what if you require some number of hosts that is in between both of them? Okay, so similarly, let's suppose in class C, it says that it will provide you 2 to the power 8, which is approximately 256 hosts. But what if you require 1,000 hosts? In that case, what will you do? It will say that you will have to go with upper class, which is class B. But that is a difficult scenario, let's suppose. So most of the IP addresses, and if you take a class B, if you take a class B IP address, then in that case, most of the IP addresses will be wasted, as you only require 1,000 IP addresses, and the certain number of IP addresses that are left out will be wasted. So in order to overcome such challenges, we are here to discuss about the classes addressing. So in classes addressing, what happens is that instead of network ID and the host ID that we studied in classful addressing, we are going to divide our whole IP address into certain blocks. And we are going to identify each block using a block ID and the hosts that are present in each block using host ID. Okay, so it is like analogous to the blocks concept is analogous to the network ID of classful addressing. And similarly, this host is actually the same as host ID. Okay, so that was the case of classless addressing. So in classless addressing, what will happen is that suppose you require 1024 number of hosts or 1024 number of devices in your particular network. So what will you do? You will just allocate the last 10 bits, which will be used for the allocation of last 10 bits, which will be used for the allocation of hosts, and the rest of the bits you will be using for the identification of particular network. So let's suppose if my IP is 32 bits, then I'm going to use just the 10 bits for the hosts, and the rest of the 22 bits I can use for identification of the block or the network in classless addressing. In classless addressing, it will be a block. Okay, so or we can also say that for the identification of a specific network, we are going to use the first 22 bits. So that is the concept of classless addressing. I hope it's making sense. Okay, now moving on. So coming to the notation part. So in the classless addressing says that we are going to use the slash notation. So what happens in the case of classful addressing? As we already know that class A requires the first byte or the 8 bits for network ID. Okay, and similarly, class B requires 16 bits for the network ID, and class C requires 24 bits for the network ID. But how are we going to identify if we are using classless addressing? Like how many bits will be used for the network ID identification? So in that case, what we do is we against up corresponding to a dotted decimal representation of an IP address, we are going to write slash x. Now, what is the meaning of this slash x? Let me tell you. So this slash x will be used. The slash is just a symbol, and the x is it's actually a representation for the number of bits in the IP address that are representing network ID. Okay, so let's suppose if I take this scenario, then in this case the IP address would be a.b.c.d/22, because 22 bits will be used over here for the network ID identification, or we could also say it as it is being used for the masking process. Okay, now coming back to the network mask. So let's suppose if I want to identify the mask for a particular network in case of classless addressing, then remember, if you guys remember that in the classful addressing, what we used to do, if I wanted to know the default mask for a specific class, then all I have to do is just put once for all the places of network ID bits. Similar criteria we are going to apply over here. So let's suppose if I have allocated 22 bits for the network ID in my this example, then what I'm going to do is I am going to write I already, like, if I have x dot y dot z dot w, then this x y z, in the x I already know that it is 8 bits, so the 8 bits are like 255. Similarly for y, it's also 8 bits, which is again 255. So this is 8 plus 8. 8 plus 8, I have already reached 16 bytes. Now I only need 16 plus 6 bytes. So what I'm going to do, I'm going to split z into 8 bytes, 8 bits, 1, 2, 3, 4, 5, 6, and 0, 0. Okay, so this is what I'm going to do over here, and the rest will be 0. So now all I have to do is calculate the binary of calculate the decimal notation for this number, and I'll have I'll have the network mask for this particular IP. Okay, so it will be actually 255.255 dot. It is 256 minus this will be 1 and 2, 3. So it's actually 6 minus 3 is 3, 253.0. Okay, so this will be the network mask for network mask that will be corresponding to this particular IP, as in which 22 bits are being used for the network part. Okay, so that is the case of default mask or network mask. Now moving on. Let's suppose if I have, so let's try to solve this question. Let's suppose if I have an IP address, and in the IP address, it's given like this 27 bits are, so slash 27, it denotes that the number of bits that will be that in this IP address, 27 bits, the first 27 bits or the most significant 27 bits are being used for the network ID identification or the block ID identification, and the rest of the bits are used for the host ID identification. So what I'm going to do over here is just that I'm going to write the IP address, and what we have to find out, we have to find the network address of the block. So for finding network address of the block, it is quite similar to the previous part as well. Like what we used to do is we have to take the IP address which is given in the question, and then we have to take the AND of that particular IP address with the network mask for that particular network or for that particular class which we are going to calculate. So similarly, what we are going to do over here, we already have the IP address. Now all we need is the default mask or the network mask for this against this corresponding to this IP address. So how are we going to calculate the default or network mask for this particular IP? So for calculating the default or network mask, what we do is we simply write the number of ones against each number of bits that are being represented using that are being used to represent the network ID. So I have already written over here like the first 8. This is 8 bits, 8 bits, and 8 bits. So I am covered with 24 bits. Now all I need is 3 more bits, and then I'll be having 27 bits. Okay. So if I write 3 more bits, and the rest will be 0, 0, 0, 0, 0, 0. Okay. And if I do the representation like if I represent it in the decimal form, then it will be 240. Okay, so now I have my network mask, and I have my network mask which is this and this. Okay, and I have my IP address. Now when I want to find the network IP, then for network IP, all I have to do is just apply the AND operation. So I have already expanded the 82 over here. Now I have to apply the AND operation of this with the network mask. So this is network mask, and this is my IP address, which was given in the question. Now network IP will be calculated as the AND operation. Now for AND operation, as we already know, like this is 240 and this is 82. So I'm going to expand both of them. So 82 is this number and 240 is just the above number. Okay, so when I apply the AND, then it's going to be 167.199.170 dot, and it's 0, 0, 0, 0. Everything else is 0 except for this number, and it will be 128. Okay, 2 to the power 7. So that will be the network IP for this block. So yeah, that was it. Now moving on, as per the CIDR rule notation, there are three restrictions when you are going to declare or when you are going to allocate a block using classless addressing. Then you have to take care of these rules in mind. Okay, so the number of requested addresses that the person is requesting, or the number of hosts that the person or the organization is requesting, it should be a power of 2. Like in the previous case as well, I requested 1024, which is simply the power of 2 and 10. Or if in case that is not like the case, if you are requesting more like 1,000 addresses, then all you have to do is like take the upper power, like so 1024 in the if you take the first 10 bits, then my in the 10 bits I'll be covered with the 1024 addresses. All the 24 of them are like visiting, but I have a specific block it is less than the number of IP addresses that are getting listed in the classful addressing. So we can go with this thing as well. Okay. Now moving on, address allocation should be continuous. Okay. So this is pretty much self-explanatory. Like the continuous, as in the meaning of continuous is that if I have an IP address 16.17.18.9 slash 17 slash 18 bits, then the IP addresses that will be allocated corresponding to this particular classless addressing, then the IP addresses that will be allocated for each host would be .9, .10, .11, and so on. So that is the meaning of continuous. Now moving on, start address of each block should be divisible by the number of addresses in that block. So what is the meaning of this sentence is that, so I'll give you the example. I'll prove it to you using the simple example that we did over here. So over here, if you will see, okay, let me write it down. So I have 32 bits over here, and out of those 32 bits, the leftmost 27 bits are being used for the network ID or the block ID. Okay, but the rest of the 5 bits are used for host ID. Okay, so if the first 27 bits are used for the block ID. Okay, so if I convert the number of hosts, like it will the number of hosts that are possible in each block of this particular IP, it will be 32 hosts. Okay, and what is the starting IP for the whole network? The starting IP for the whole network is this one, if you will see. So that is what we calculated over here as well. Okay, so it says that the number of IP, the start IP, which is the network IP 128, it should be divisible by 32. Actually it should be the whole number, like expanding this number and this number and this number and all of them, and then converted all of this term into binary. And similarly, like here also we have converted it into binary. So for right now, what I am trying to say over here is, if you convert it into base 26, like the dotted decimal form, then it will be 0.0.0.32. And if you will divide it, then it should be 0. It should be completely divisible as in. Okay, so if I right now divide it, then it will give me a remainder of 4. Let me try and divide it out. So it will be 8. Let's try and divide it out by 8. 8, 5, 8, 8 for the 8 for the 32. Then it's again going to be 8 on the 8 and 4. It's the 40. Yeah, it's 4. So that is the case. So the network, so the start address of the network should completely divide the number of hosts that are possible in a particular block. So that is the case of the third rule. So that is all in the classless addressing. And yes, so these are the CIDR rules that we should keep in our mind before allocating a block to a particular organization or to a person requesting the IP addresses using classless addressing. So that will be all for this video. In the next video, we are going to look for the special addresses. Like there are some addresses that are known as the special addresses, and why are we going to study about them? So we'll discuss it in the next video. So thank you all for watching. Have a nice day.